Hello and good morning. Let's take a look. Week 4. Homework, classwork is due. Also, you'll be getting a grade for Albert I.O., which was Friday and Saturday. Let's take a look here. Also, if you have math fees, see me today. Today's the last day I'm collecting. All right, so look here. They give you the 3 sets. This represents what? Does anybody know? It represents the complement. So let's take a look here. So S is all of these numbers. And you want the complement. So you want everything else. So you don't want the 2, the 4, the 6, or the 8. So the complement would be everything else. It would be 1, 3, 5, 7, 9, and 10. The complement of T, it's numbers less than 10 but odd numbers. So it'd be this one, this one, this one, all the odd numbers less than 10. So your answer, complement, would be everything else. So it'd be 2, 4, 6, 8, and 10. And that's how you do it. All right? Copy this down if you don't have it already. Well, are the whole numbers a subset of the natural numbers? Well, the whole numbers are right here. Remember, it has a hole in it. A hole. And the natural numbers are here. So are these inside of here? The answer is no. Are the natural numbers a subset of the whole numbers? Yes, these numbers are inside of there, so this would be true. Is the null set a subset of the universal set? Yes. This is true by definition. Okay? The null set is a subset of every set. Write that down. The null set is a subset of all sets. Memorize that. The complement of the universal set is the null set. Right? If you take everything in the universal set and then you want everything that's not in it, it would be the null set. Okay, copy down these notes. We're going to finish up this section. This represents what? Does anybody know? That is called the subset. So, what is this one called? This one is called the proper subset or proper set. What's the difference? I'm going to show you. So let's say you have R and you want to know if R is a subset of S. Well, yeah, these are included here. So this would be yes, true. On the other hand, let's say this is your R and you want to know if R was a proper set of S. Are all these inside of here? Yeah, they are. But it's exactly the same. So this would be false. It cannot equal. So a proper set cannot equal the other set. If it does, then it's not proper. Write that down and memorize it. All right, let's go on. Suppose, and copy all this down, suppose you have 4 toppings. And you want to know how many subsets do you have? Well, the formula is 2 to the n power. So it's going to be 2 to the 4th power. It's not 8. If you put 8, it's wrong. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this would have 16 subsets. How many proper sets? Remember, it can't equal. So it's going to be 16 minus 1. So there's 15. Okay, so you have to subtract the set that's equal. Today, you have an assignment 2.2, page 65, 1 to 36. Let's turn our attention now to college algebra. Okay, so for college algebra, this one is a perfect square and that one's a perfect square, but it's a plus. You can't factor it, so this one is prime. This one is the difference of two squares, so it's going to be x plus 4 and x minus 4. This one right here is the difference of two cubes and has a formula. Now, the formula uses both of these, and then it's going to be the first one squared and the last one squared. And then it's multiplying these two. And I think this one has two pluses, and you can double check it. All right, let's go on to today's work. Copy these two down. Now pay attention because these are harder. First of all, you can't factor anything out. Here's how you do it. When this is not a 1, you got to multiply these two. So 3 times 5 is 15. Now you're going to write all the factors. And there's only 2. You look at your chart I gave you a long time ago. A negative and a negative. Get your chart out. Equals a plus and a minus. Turn to your neighbor and get it if you need to. This is subtract. So 5 minus 3 gives me 2. So in place of this 2x, we're going to substitute these two. So you're going to rewrite the first term. You're going to rewrite the last term. And in the middle, you're going to substitute a 3x into 5x. Since you want a minus, you're going to put the minus with the bigger one. And then here, you're going to do group factoring. So you're going to take out a 3 and an x, and you're left with x plus 1. Here, you're going to take out a negative 5, and you're left with the x plus 1. So when you factor out a negative, which I did, that sign changes to a plus. This is now the same as that. So you're going to take out an x plus 1, and you're left with 3x minus 5. It doesn't matter which one comes first or second. Let's do one more, and then you're going to have a little work to do. So let's try this one right here. First thing you do is, do they have anything in common? The answer is no. You're going to multiply and get 60. 1 times 60, 2 times 30, 4 times, or 3 times 20, 4 times 15, 5 times 12, and 6 times 10. I think that's it. You're trying to get 19 right here. So it's got to be that. A plus and a plus is going to give you a plus and a plus. So you're going to be adding. There it is. So you're going to substitute. You're going to rewrite the first one, rewrite the last one, and you're going to substitute a 4x and a 15x. And then you want both of these to be pluses, according to the chart. You're going to factor out an x. Here you're going to factor out a 3, and it should be the same as that. Okay, so this is the same as that, so you're going to take 5x plus 4, and then you're left with x plus 3. And that's how you do that. So today I'm either going to give you a worksheet or you have to copy this down. So right now, either way, copy that down and put worksheet A, week 4, and put a date on it. And then copy the rest of it. Have a good morning.